Welcome to the second lecture on conic sections. So, in the first lecture we discussed about parabolas. Now, in this lecture we will talk about ellipse, which is generalization of circle. So, let us first define what do we mean by ellipse. So, the definition is an ellipse is the set of all points in a plane that are an ellipse is the set of all points in a plane such that the sum of the distances from two fixed points in the plane is a constant. So, what we have is we have two fixed points, let us call them f 1 and f 2, and then we are looking for all the points in this plane such that if we look at the distance of the point, let us say P is a point, then we have the sum of the distance of this point from these two fixed points f 1 and f 2. So, we have P f 1 plus P f 2, this is a constant. Okay. So, a special case is if these two points are same. So, if f 1 is equal to f 2, then what do we get? So, we have only one point and then we are looking for the sum of the distance of points from these two points which are identical. So, we have P f 1 is equal to P f 2. So, we have only one point f, this is f 1 as well as f 2, and then if I take any point P, the sum of the distance of this point from f 1 and f 2 is twice the distance of this point P to f. So, if this distance we call r, then P f 1 plus P f 2 is equal to 2 r, which is a constant. So, what we get is we get a circle. So, if these 2 points coincide, then we get a circle. What do we get if these 2 points are not the same? So, ellipse is a special case of circle. If I have now this point f 1 and f 2, and then we look at all the points such that the sum of the distance from f 1 and f 2 is constant, we get a curve like this. So, if I take any point P, this plus this is same as this plus this, same as this plus this. For any point P, if we take P 1, P 2, P 3, P 4, P I f 1 plus P I f 2 is a constant. So, just like to draw a circle, you can take a fixed point center of the circle, and then you take a fixed radius r, and you can take a thread join from here, and then if you just rotate it about this, you get a circle. In this case, what you can do is, if you take two different fixed point, take a thread and then take this at some point, and then if you just keep the length of the thread same. So, or you keep rotating, you get this ellipse. So, some terms that we will use, these two fixed point, the two fixed points are called the foci of the ellipse. Foci is plural of focus. So, there are two foci of the ellipse. The midpoint between the two foci, this is called the center. So, center, this is the midpoint. On the line segment. Joining the foci. Also, if I look at the line passing through this these two foci, this is called, let me call this A and B, this is called the major axis. And the line segment which is perpendicular to the major axis and passing through the center, this is called the minor axis. So, major axis, this is the line segment, joining two points on the ellipse, passing through the foci, and minor axis is the line segment passing through the center and perpendicular to the major axis. Also, we define vertices of an ellipse. These are the end points of the major axis. So, let us draw an ellipse. We have, this is the center, these are the foci f1, f2. Write this A, B and C, D. So, A and B are vertices. This is AB is the major axis, CD is the minor axis, F1 and F2 are foci, and let us call this point O as the center. So, O is the center. Okay. So, now let us consider an ellipse whose foci lie on the x axis, and let us say the center is at the origin. So, we have origin is here and x axis, y axis. Because the center is the midpoint of the foci and the foci lie on the x axis, if we write this f1 and f2, the distance of this to the center O is same. So, if the coordinate of f2 is c comma 0, then f1 will be minus c 0, and let us say the vertices will also be on the x axis. So, say the vertices A, B, these are coordinates minus a comma 0 and a comma 0, and let us say the minor axis we have, this is 0 comma b and 0 comma minus b. So, what is the relationship between A, B and C? A is the length of the half of the length of the minor axis, B is half of the length of the major axis, this is A, this is our B, and C is this distance. So, now by the definition of ellipse, we know that any point on the ellipse, the sum of the distance from the foci f1 and f2 must be constant. So, if we look at this point B, what is the distance B f 1 plus B f 2. What is B f 1? B f 1 is equal to B o plus O f 1 plus B f 2 is B o minus O f 2. Now, what is the distance of B to O? This is A, O to f 1 is C. So, A plus C plus B O is again A, O f 2 is C. So, A minus C. So, C cancels and this is equal to 2 A. So, B f 1 plus B f 2 is equal to 2 times A. So, similarly, let us calculate what is the distance. So, let us call this point C and D. What is C f 1 plus C f 2? C f 1 is equal to, if I draw this C f 1 is equal to square root of this C square plus B square. So, C f 1 is square root of B square plus C square, and C f 2 is again same. This is square root of B square plus C square. This is also square root of B square plus C square. So, therefore, C f 1 plus C f 2, this is equal to twice of square root of B square plus C square. Now, the definition of ellipse is that the sum of the distance of any point from the two foci is a constant. So, since B f 1 plus B f 2 should be equal to C f 1 plus C f 2, we get two A is this distance equal to 2 times square root of B square plus C square, which implies B square plus C square equal to A square, or C square is A square minus B square. So, C is square root of A square minus B square. So, this is the relation between A, B and C, that if you have the semi major axis, length of the semi major axis and semi minor axis are A and B, then the distance of any of the foci to the center C is given by C equal to square root of A square minus B square. Definition: we define eccentricity of an ellipse this is E is equal to C by A. So, this is the ratio of the distance between the foci and the distance between the vertices. Right, because if you look at an ellipse, then the foci, the distance between the foci f1 f2 is equal to 2 c, and the distance between the vertices a b is equal to 2 a. So, f1 f2 divided by a b, this is 2 c over 2 a or equal to c over a. So, we can write c in terms of the eccentricity. So, c is equal to a times e. Note that since c is smaller than a, eccentricity will be less than 1. Next, we will try to derive a formula for the standard ellipse. So, let us take an ellipse with center at the origin and foci on the x axis. So, we have the origin, and then we have this is a comma 0, minus a comma 0, then the foci f1 f2 is minus c comma 0 and c comma 0. Suppose p x y is any point on the ellipse. Okay, so, we know that p f1 plus p f2 is a constant, and we have already calculated in previous slide. If we take this point B, if this is A and B, then B f1 plus B f2, this we calculated is equal to 2a. So, P f1 plus P f2 must be equal to 2a for every point P on the ellipse. Now, what is P f1? Is x plus c square plus y square square root plus P f2 is x minus c square plus y square square root equal to 2a. Now, from here we will derive an equation. So, this is same thing as x plus c square plus y square equal to 2a minus square root of x minus c square plus y square squared. Which implies we get x plus c square plus y square equal to 4a square plus x minus c square plus y square minus 4a times square root of x minus c square plus y square. So, let us take the square root one side. This means 4a times square root of x minus c square plus y square. This is equal to, see, y square cancels. So, 4a square plus x minus c square minus x plus c square. This is equal to minus 4 x c. So, we get 4a times square root of x minus c square plus y square equal to 4 times a square minus c x. We can cancel 4 and then let us square both sides. We get a square times x minus c square plus y square is equal to a square minus c x whole square, which is a to the 4 minus 2 c a square x plus c square x square. So, we get a square x square plus a square c square minus 2 a square c x plus a square y square equal to a to the 4 minus 2 a square c x plus c square x square. We can cancel this term 2 a square c x, and then we get a square minus c square times x square plus a square times y square equal to a to the 4 minus a square c square, which is a square times a square minus c square. But we have seen the relation between a, b and c, which was c square is a square minus b square, or a square minus c square will be b square. So, we will write a square minus c square, this is b square, this is b square. So, we get b square x square plus a square y square equal to a square b square. Now, dividing by a square b square, this gives x square by a square plus y square by b square is equal to 1. So, this we have obtained as the equation, this is the equation of an ellipse whose vertices are at minus a 0 and a 0, and center, of course, in this case center at the origin 0 0, and in this case the length of major axis is 2a, length of minor axis is 2b. So, we will get ellipse like this. This is the case where A is bigger than B, or we can have the major axis is smaller than the minor axis. So, this is the equation for A less than B. Both are this equation x square by A square plus y square by B square equal to 1. Now, from this equation we can see that this is symmetric about both x and y axis. Also, if A is equal to B, then we get a circle. So, circle is a special case of ellipse in which the major axis and minor axis are of the same length. So, we will get x square by A square plus y square by A square equal to 1, that is x square plus y square equal to A square. So, this is the circle centered at origin. Centered at origin and radius A. Now, just like we defined latus rectum for parabola, we will define latus rectum for ellipse. So, this is line segment with end points on the ellipse. Passing through a focus and perpendicular to the major axis. So, if we have an ellipse like this, this is the center, we have focus f1 f2, then let me draw. The latus rectum is drawn in the red here. What is the length of this latus rectum? So, if we look at So, we have this point as a comma 0, this is the origin, this is one of the focus C comma 0. Now, let us take this point P here, then P will have coordinate some C comma L, and then this will be C comma minus L, this is let us say F. This is point Q. So, let P f equal to Q f equal to L, then we need to find length of lattice rectum is 2L. Now, the coordinates of P is C comma L. What is C? We have seen that C can be written in terms of eccentricity as A e comma L. Since P lies on the ellipse x square by a square plus y square by b square equal to 1, we get a square e square by a square plus L square by b square equal to 1. So, this gives L square by b square equal to 1 minus e square, which is 1 minus e square is c square by a square. So, L square by b square equal to a square minus c square by a square. A square minus c square is b square by a square. So, this will imply L square is b to the 4 by a square, or L is b square by a. So, 2 L is the length of the lattice rectum, this is equal to 2 b square by a. This is length of lattice rectum. So, length of lattice rectum for an ellipse x square by a square plus y square by b square equal to 1 is 2 b square by a. Now, let us discuss some problems. Find the foci, vertices, eccentricity, and length of lattice rectum for the ellipse (16 x square plus y square equal to 16). So, first we will write the equation in the standard form. So, dividing by 16 we get x square plus y square by 16. So, I will write x square by 1 square plus y square by 4 square equal to 1. So, this implies a is equal to 1 and b is equal to 4. So, in this case a is less than b. So, the foci will lie on the y axis. So, here the ellipse will look like this. So, we have this is 1 comma 0 minus 1 comma 0, 0 comma 4 and 0 minus 4. So, the foci in this case will be on the y axis. So, this will be f1 and f2. f1 is 0 comma minus c, f2 is 0 comma c, and eccentricity in this case E will be ratio of c over, here the major axis is the y axis. So, c over b, right. And we have this c square in this case will be b square minus a square. So, this is 4 square minus 1 square, this is 15. So, c is square root of 15 and eccentricity E is c over b, which is square root 15 over 4. Foci, so therefore, the foci are at 0 plus minus c root 15 and length of lattice rectum. So, in this case the lattice rectum will be this. So, we derived this formula where the foci was on the x axis and length of lattice rectum was 2 b square by a. So, if you just change the x and y axis, you will see that if the foci lie on the y axis, length of lattice rectum will be 2 times a square by b, which is a is 1 here, 2 by b square, sorry, b is 4. So, 1 by 2. This you can directly also calculate here. We have this ellipse. Foci is this point is 0 square root of 15 Then if you want this point here, this is my f, this point P will be some x comma root 15, and we have x square by 1 square 16 x square plus y square is root 15 square equal to 16, which means 16 x square equal to 1, means x is 1 by 4. So, this x is 1 by 4, length of the lattice rectum will be this p q is 2 x, which is 1 by 2, which we can get directly from using this formula also. Let us look at one more problem. Find the equation of the ellipse whose center is at 0 0, major axis is on the y axis and passes through these 2 points 3 2 and 1 6. So, we have this figure, the major axis is on the y axis. So, we will write 0 comma a, 0 minus a as the vertices, this is the origin, and this is b comma 0 minus b comma 0. So, the equation is x square by b square plus y square by a square is equal to 1. Note that here I have taken this as b comma 0 and 0 comma a. So, now this is the equation of an ellipse whose center is at the origin and major axis on the y axis. Ellipse centered at 0 0 and major axis on the y axis. Now, we are given that this ellipse passes through 2 given points. So, we can use that to find the values of a and b. So, since it passes through points 3 2 and 1 6, we get using 3 2 we get 9 by b square plus y is 2, 4 by a square equal to 1, this is one equation, and it passes through the point 1 comma 6. So, 1 by b square plus 36 by a square is equal to 1, this is equation 2. So, from equation 1 and 2 we can find the values of a and b. So, if you see, if I do 9 times equation 1 minus equation 2, this will imply 81 by b square minus 1 by b square. So, 80 by b square equal to 9 minus 1 is 8. This implies b square is equal to 10. and therefore, if I put b square equal to 10, one implies 9 by 10 equal to 9 by 10 plus 4 by a square equal to 1, which means 4 by a square equal to 1 by 10. So, a square is 40. So, b square is 10 and a square is 40. Therefore, the equation is x square by b square 10 plus y square by a square 40 equal to 1. Okay, so we will stop here for this lecture. In the next class, we will learn about hyperbola and also some more problems on parabolas and ellipses. Thank you.